Okay, let's start. So last day we have started differentiation with first principle method. Then we identified 16 different functions and their derivatives. 16 different functions and their derivatives. Then today we need to go further, how to differentiate composite functions. Then composite function mean we have 16 different functions. So by adding those functions, we can get another new function. By multiplying, by dividing, by subtraction, we can get new functions. Then those are we call composite functions. Then sin x just function. Then sin x plus cos x composite function. Okay. Then sin x divided by cos x, that will be tan, but we can consider as composite function. Then x divided by sin x, x plus sin x, 2x minus sin x, those are composite functions. Then to differentiate those functions, we have clear rules. Then we have to analyze that rules today. Okay, write down. Differentiation of composite functions. Differentiation of composite functions. Okay, under that write down. There are 16 different functions. Then composite function is made. Composite function is made with algebraic operations with those functions. Then to differentiate composite function, use the following rules. Okay, now see this, Anna. So last week we did about first principle method. Now today we are going to differentiate that function directly. Okay. Then here first rule, y equal constant time function, k times fx. Here constant time function. It's like y equal sin x just function, y equal 2 sin x, y equal 3 sin x, those are composite, y equal half sin x, composite function. Here constant time function. Then here derivative technique, dy by dx equal constant time derivative, f dash x, constant time derivative. Then dy by dx equal constant time derivative. That is differentiation technique. Then as an example, you consider y equal x to the power 4. So last day I told you about special function type y equal x to the power n. Say this, y equal x to the power n derivative. You have to remember here dy by dx equal nx n minus 1. Nx n minus 1. X to the power something, you can write y equal dy by dx equal nx n minus 1. Then here you consider y equal x to the power 4. Right derivative dy by dx equal 4x cubed. Y equal x to the power 3. Dy by dx equal 3x squared. Nx n minus 1. Y equal x to the power 1/3. You say dy by dx equal 1/3 x to the power 1/3 minus 1. Likewise, you can differentiate. Then y equal x to the power half, that means root x. Then dy by dx equal nx n minus 1. Then y equal x to the power minus 2, you say dy by dx nx n minus 1 minus 2x minus 2 minus 1. Thereafter you can simplify further. Okay. Then y equal x to the power 4, say 2 times x to the power 4. Y equal 2 times x to the power 4. Then here constant time function derivative, constant time derivative, constant time derivative. Here 2 times x to the power 4. No? Then say dy by dx. Here there's constant 2 times x to the power 4 derivative, 4x cubed, that's it. Then 8x cubed. Then y equal 1/3 sin x dy by dx. Here 1/3. Then go to that table, sin derivative cos, sin x derivative cos x. Then write here cos x. Then y equal 2 tan x. Then dy by dx. Then here constant time function, constant time tan derivative. Go to that table, tan derivative sec quad. Then sec quad x, sec quad x. Then y equal minus 4 x to the power 5. Then dy by dx. Here constant time function, then constant time x to the power 5 derivative. X to the power 5 derivative like nx n minus 1. Then here 5x 5 minus 1. Then minus 20x to the power 4. Likewise, you can differentiate. So here we get derivatives. So derivative means tangent drawn to the curve at general point. Tangent drawn to the gradient of the tangent drawn to the curve at general point. Okay, that's how we differentiate first one. Okay, okay. Write down first rule. Rule number 1. Rule number 1. Write down scalar multiple rule. Scalar multiple rule. Scalar multiple rule. Following. Scalar multiple rule. Okay. Write this rule. Y equal constant time function, derivative equal constant time derivative. Constant time derivative. Then when differentiating function, you have to remember that 16 different function derivative, we can apply them directly. We can apply them directly, okay? Okay. Then you need to write these examples, but before that, you better write here this one. Direct derivative like x to the power n type. X to the power n type. Better write that one at first. Y equal x to the power n type derivative. Write this one. Okay. Thereafter you write this scalar multiple type. Constant time function means scalar multiple. Okay. Then you write derivatives of these functions soon. Do it. dy by dx 4 into 1/3 x to the power 1/3 minus 1. dy by dx 3 into minus 5 x minus 5 minus 1. You can simplify. dy by dx here 2 times here x to the power minus 2 na? Upstairs take x to the power minus 2. Here first you better write 2 of x square 2 times x to the power minus 2, then differentiate minus 2 x minus 2 minus 1. You write minus 3 divided by 2 x to the power minus 3, then minus derivative minus 3 over 2 minus 3x minus 3 minus 1. Then here dy by dx root 2 4x cube. Likewise you can differentiate. Okay. Now just come to this. So I told you for constant always derivative 0. For constant, always derivative 0. Constant derivative 0. X to the power n derivative n minus 1. Ex derivative ex. lnx derivative 1 over x. Sin derivative cos x. Cos derivative minus sin x. Tan derivative sec quad x. Cosec derivative minus cosec x cot x. Sec derivative sec x tan x. And cot x derivative minus cosec quad x. Sin inverse 1 over 1 minus x square root. Cos inverse minus 1 over 1 minus x square root. Tan inverse 1 over 1 plus x square. Okay. Sec inverse 1 over modulus x square minus 1 root. Cosec inverse minus 1 over modulus x times x square minus 1 root. And cot inverse minus 1 over 1 plus x square. Likewise, you have to remember. Then in that case, we have 1 for constant derivative 0. For constant derivative 0. Okay. Then y equal 1 is derivative, just dy over dx 0. Constant mean parallel to x-axis now. Constant mean parallel to x-axis. Then parallel to x-axis line has gradient 0 always. That's why we take gradient 0, derivative 0. Then y equal minus 2, derivative 0. Then y equal 1/3, derivative 0. Y equal root 5, derivative 0. If you have only one single constant or constant separated, you say derivative 0. Then here the thing, y equal constant, then corresponding derivative dy by dx equals 0. K constant for single constant. Okay. Previous rule, constant time function, identify the difference. Only one single constant, derivative 0, then constant time function, derivative mean constant time derivative. Okay. Constant times function. Okay. Just note this one. You know, but anyway, just write. Constant derivative 0. Come to next rule. Second rule. See this one we call sum rule. Sum rule. Y equal fx plus gx. Sum of two functions here. Then we say derivative dy over dx equal f dash x plus g dash x. This is called sum rule. If you have minus here, you can do same. So constant time function derivative, constant time derivative. Sum of two function derivative, derivative sum. See, y equal x to the power 4 plus x to the power 3. Say derivative now. X to the power 4 derivative 4x cube. X cube derivative 3x square plus sign separated. Y equal x plus minus sin x. Then dy by dx. dy by dx equal x derivative 1 times x 1 minus 1, no? 1 times x 1 minus 1. N x n minus 1 x derivative. Minus sin derivative, go to table, that is cos x. Then here x to the power 0 1 minus cos x. Then y equal 3x to the power 4 minus 2x square plus 1. Now dy by dx. Here constant time function 3 times x to the power 4 derivative, say 4x cube, minus 2 times x square derivative, we say 2x. 1 derivative, it is single constant 0. Okay. So for addition of functions or subtraction of functions, you can write derivative sum. Derivative sum, we call that is sum rule. Sum rule. Okay. Second rule, write down sum rule. Write the sum and the examples. Okay. Now, while you are doing that, you better remember these derivatives again. You better remember these derivatives. Huh? See, y equal x. Y equal x. X to the power 1. Then here derivative, you better to remember directly. Dy over dx 1 x 1 minus 1, no? Then direct results 1 times x to the power 0, it is 1. Then you remember directly dy over dx equal 1. Dy over dx equal 1. Then y equal n times x. Now you directly remember dy by dx n times x derivative, then 1. Then we get n. X derivative 1. X derivative 1. Then n times x derivative, just n. N times 1. No? X derivative 1. Then constant time function derivative, constant time derivative. X derivative 1. Okay, better remember directly. Then y equal root x. Here x to the power half. Then dy by dx nx n minus 1, half x, half minus 1. Simplify. X to the power minus half. You take that one downstairs. X to the power half. Then finally 1 over 2 root x. Then you better remember here derivative 1 over 2 root x. Root x derivative 1 over 2 root x. Likewise, you better remember. Okay. Then there's another one. Better remember directly. Y equal 1 over x. Here x to the power minus 1. No? Then now proceed here. Dy by dx n x n minus 1 minus 1 x to the power minus 2, then minus 1 over x squared, minus 1 over x squared. Then better remember directly, minus 1 over x squared, minus 1 over x squared. Okay, then dx over dx, here function x, no, dx over dx 1, d root x over dx, instead of y I have put root x, d root x, y mean root x, you say 1 over 2 root x, d 1 over x over dx, remember minus 1 over x squared, minus 1 over x squared. You better remember these relations directly. Okay, put that note. Put that note. Do alone. Differentiation, very simple lesson. You have remember some small things, but it is very simple. After that, you go to here and find derivative. Okay, I just need only differentiation first step only. Yeah? No need to simplify, just write first step. derivatives. Here dy by dx cos x derivative minus sine, dy by dx 4x cube 3x squared, dy by dx 2 times 1 sin x derivative cos, dy by dx 3 into x squared derivative 2x, 4 into x derivative 1, constant derivative 0. Here cube root. Then dy by dx square root derivative 1 over 2 root x. 1 over x derivative minus 1 over x square. Then cube root 1/3 x, 1/3 minus 1. Here cube root 1/3 x. Then here dy by dx 3 times 4x cube minus 4 times x to the power minus 4 minus 1, constant derivative 0. Constant derivative 0. Okay. Now go to these questions, write derivatives. I need first step only. Do it. Dy by dx 2 sec qua x minus sin x. Dy by dx 2 times 4x cube 3 times 3x square 5 times x to the power 4. Dy by dx x derivative 1, 2 derivative 0, sin derivative cos. Here this is sec. Then dy by dx then sec x tan x. You know how to differentiate only addition and constant multiple. Division you don't know, okay, division you don't know, then multiplication again you don't know, then you convert that 1 over cos into sec, then we know direct derivative, no? But there's another technique, okay, then dy by dx, tan derivative sec qua, sec derivative sec tan. Then here you don't know power, here this type of relation, but when you expand you can differentiate. 16 x to the power 6, 8 x cube plus 1, here binomial. Then differentiate dy by dx, 16 times 6x to the power 5, 8 times 3x square, 1 derivative 0. 1 derivative 0. Then there's another technique to differentiate this one. We have function of function type, but you know only sum of two functions and constant multiple only now. That's why we have to convert here addition by expanding. Okay, here these are direct derivatives. Last week we done about first principle. Then first principle method too long, but direct derivative very simple because we have to remember some derivatives and rules. That's it. Okay. Now you go further. Differentiate. Do soon. Take time. First line enough. Huh? Here dy by dx 9x to the power 8, 3 times 5x to the power 4, 4 times 2x plus 1. Here dy by dx 5 times 3x square, 2 times root x 1 over 2 root x. You can simplify. Then dy by dx, you apply previous relations. Huh? Root x derivative 1 over 2 root x. Root x derivative 1 over 2 root x. 1 over x derivative minus 1 over x squared. X derivative say 1. Okay. Then here 3 x to the power 5, 5x to the power 4. Here 7x derivative 7 times 1. Here dy by dx 3x square, root x derivative 1 over 2 root x. Then here 3 over 2 dy by dx 3 over 2 x square derivative 2x. 5 here 5 over x square means x to the power minus 2. Then x to the power minus 2 derivative minus 2 x to the power minus 2 minus 1. Here 2, this is cube root x. Then that goes to upstairs. No? Then x to the power minus 1/3. Here x to the power minus 1/3 derivative minus 1/3 x to the power minus 1/3 minus 1 nx n minus 1 constant 5 derivative 0. Constant 5 derivative 0. Okay. Then here that's technique to differentiate division, but still I haven't tell that. Then you can separate denominator first. Separate denominator here. X square divided by x, x. X over x 1, 3. Then 1 over x. Then differentiate. Dy by dx 3 times x derivative 1. Constant derivative 0. 1 over x derivative minus 1 over x square. 3x derivative 3, constant derivative 0, 1 over x derivative minus 1 over x square. Okay, try these questions now. I need first step only. Do it. Okay, here fourth one, there's mistake here. Fourth one, here minus 1 over x, minus 1 over x derivative minus 1 over x square, then minus 1 over x square, right? Here fourth one, then that will be 1 over plus 1 over x square. Here plus 1 over x square. Okay, continue. Do alone. For x squared, you have to simplify that. Huh? Here 4x square minus x plus 3. 4x square minus x plus 3. Divide by root x. Let's do this way. Separate denominator. Here x square divided by root x, 2 minus half. Here x divided by root x. 3 divided by root x means x to the power minus half. For x to the power 3 over 2 minus root x, 3 x to the power minus half. Then dy by dx for 3 over 2 minus 1. Root x derivative 1 over 2 root x. 3 x to the power minus half n x n minus 1. Nx n minus 1. Now need to simplify, yeah? Now need to simplify. First, simplify, separate into x to the power n terms. Separate into x to the power n terms, then differentiate. Okay, then y equal x plus 1 3x squared minus 4. Expand 3x cube minus 4x plus 3x squared minus 4. Then differentiate 9x squared minus 4 6x. If you can write with simplification, just write, but don't do any mistake, because at first instant we have to differentiate the function without any error. If we get error, definitely then the other remaining part will be wrong. Therefore, at once you have to practice differentiation step. Then y x times 3x square minus root x. 3x cube, here x times root x. 3x cube, x to the power 1, x to the power half, x to the power 3 over 2, 1 plus half. Then differentiate. Here 9x square, 3 over 2x, 3 over 2 minus 1, nx n minus 1. Okay, then y equal 2, here cube root x no, times x plus 1, expand 2x times cube root x plus 2 cube root x. Here x to the power 1 plus 1/3, no? Then 4/3. X to the power 4/3. 2 x to the power 1/3. Here cube root. dy by dx 2 4/3 x to the power 4/3 minus 1. 2 1/3 x to the power 1/3 minus 1. You can simplify. No need to simplify now. Then y equal x times x minus 1 x plus 2. Then first expand x square with this x cube plus x with this plus x square minus 2 with this x minus 2x. Then differentiate. dy divided by dx 3x square 2x minus 2. Okay. Check your answers. Check your answers. Okay. Now see next rule. So now up to now, we know how to differentiate just constant. Okay. We know how to differentiate special different functions using first principles, and we have result. No? Then by using those results, we can differentiate further functions. Then constant time function derivative mean constant time derivative. Then sum of two function derivative, sum of derivatives. Now there are special thing, multiplication and division. Okay. Then we have two rules we call product rule and quotient rule. They are differ than the previous relations. Okay, write down next third one. Product rule. Okay, now see this one. Here we consider multiplication of two functions, product of two functions. See, y equal fx times gx. Here product of two functions. Y equal fx times gx. Then corresponding derivative, now you remember, dy by dx equal here fx times g dash x. Plus gx times f dash x. That's how we differentiate. So these rules we obtain by first principle. Later we will see how to prove them. Later we can see how to prove them. But anyway, now remember, if you have product of two functions, like fx times gx, fx times g dash x plus gx times f dash x. Fx times derivative of gx plus gx times derivative of fx. Very special. Then here we call product rule. And consider y equal x times sin x. See derivative dy by dx. X times sin derivative cos. Sin x times x derivative 1. Y equal x square plus 1 times cos x. Then dy by dx. X square plus 1 times cos x derivative. Cos x derivative minus sin x. Plus cos x times x square plus 1 derivative. X square plus 1 derivative. Here x square derivative 2x plus 1 derivative 0. Okay. Then if we have product, we have to apply that. So previous all cases also we had product and divisions, but we did that one by expanding. No? By expanding you can remove the product, but these type of product we can't remove. These type of products still remain as it is. Therefore, you have to remember this rule. Fx times gx, fx times g dash x plus gx times f dash x. That is product rule. Say another example. Y equal x square times ln x. Then dy by dx. X square times ln x derivative. 1 over x plus ln x times x square derivative. X square derivative 2x. You can simplify then. Okay, that's how we differentiate. Here all the result derivative mean gradient of the tangent at a general point to the curve. No? Here this derivative represent Gradient of the tangent. Gradient of the tangent. Then by using this gradient we can do many things later. But anyway, you have to remember how to get derivatives. Okay, write all. Do alone. After that you go here. Differentiate. I need only first line. Need only first line and write without any error. dy by dx, x plus 2 times ln x derivative 1 over x, ln x times x plus 2 derivative 1, dy by dx, root x plus 5 times ex derivative ex plus ex times root x plus 5 derivative 1 over 2 root x, 5 derivative 0. Here dy by dx, ex times sin derivative cos sin x times ex derivative ex, dy by dx, here 2x minus 1 times cos x plus sin x, cos x derivative minus sin x plus sin x derivative cos x, plus cos x plus sin x times 2x minus 1 derivative 2 into 1, 2 into 1. Okay. Apply combination first. First identify function combination. First identify function combination. Function combination mean there are 16 different functions. You check whether they are like addition or division or multiplication, constant time function, likewise. Okay. Then dy by dx, here x square plus 1 times 3 ln x minus 2 derivative 3 times 1 over x, 3 ln x minus 2 times x square plus 1 derivative 2x. Here dy by dx, x times sin derivative cos sin x times x derivative 1, x square times cos derivative minus sin, put bracket, cos x times x square derivative 2x, 2x. Okay, go to here, do them. Okay. Then dy by dx, ex times 2 sine derivative cos, 3 cos derivative minus sine, plus 2 sin x plus 3 cos x. Ex derivative ex. 2x plus 5 times derivative, ex derivative ex, ln x derivative 1 over x, plus 3 e to the power x plus ln x times 2x plus 5 derivative, 2 times 1 plus 0. Here dy by dx, here we have constant separated. Then first go to constant time function relation. Then constant time derivative. When you differentiate this, we have product. Then within this bracket write sin x plus cos x times derivative of this 2 tan derivative sec qua plus 2 tan x plus 3 derivative of sin x plus cos x. Derivative of sin x plus cos x. Sin derivative cos x derivative minus sin x. Okay. Then x square plus 2x minus 1 plus ln x. dy by dx, x square plus 2x minus 1 times ln x minus 1 derivative 1 over x, 1 derivative 0 plus ln x minus 1 times here 2x minus 1 derivative 2. Here 3x square minus 2x plus 5 times derivative of 2 ln x, 2 times 1 over x, x derivative 1 plus 2 ln x plus x times here 6x square, derivative 6x square minus 2, 6x square minus 2. Then last one, here this one, dy by dx 4 root x plus 2x minus 1 over x times derivative of 2x plus 3. It is 2 times 1, 3 derivative 0. No? Then 2x plus 3 times, here 4 root x means 1 over 2 root x. 2 x derivative 1 minus 1 over x derivative minus 1 over x square. This goes to plus. Check signs. Huh? Okay. Then we have another relation, that means division. Division we call quotient rule. Check it now. Quotient rule. Consider function y equal fx divided by gx. Division of two functions. Division of two functions. Then here dy by dx. Dy by dx, here denominator is square, denominator times derivative of numerator minus numerator times derivative of denominator. Here the rule we call quotient rule. quotient rule. This relation we obtain by using first principles. When you have division of two functions, apply that rule. Check y equal x over sin x. Then we have division of dy by dx. Denominator is square. Denominator is square. Denominator times derivative of numerator. Denominator sin x, x derivative 1 minus numerator times derivative of denominator. Sin x derivative cos x. That's how we do. Okay, we have rule using first principles. This is the rule. Then if you have division, denominator is square, denominator times derivative of numerator minus numerator times derivative of denominator. That's the rule. See, y equal e to the power x over 2x minus 1. Then dy by dx. Denominator is square. Denominator times derivative of numerator minus numerator times derivative of denominator. Y equal x 2x minus 1 over x plus 1. Then dy by dx. Denominator is square. Denominator times derivative of numerator minus numerator times derivative of denominator, x plus 1 derivative 1. Okay. Write quotient rule and the examples. Here 6x gone away, 6x minus 2, 6x minus 2. Okay, right? Okay, now you try. You try these questions. Do alone. Y equal x plus 1 over x minus 1. Y equal sin x plus 1 over sin x minus 1. Y equal 2x over x square plus 1. X over x square plus 1. 2x minus 1, x square plus x plus 1. Okay, do them. I need only first line, first differentiation line only. Okay. Now differentiate dy by dx, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Dy by dx, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Dy by dx, denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Then denominator square, denominator times derivative of numerator, numerator times derivative of denominator. Okay. Okay, now we know up to this. We know first principle of differentiation. Okay, first principle of differentiation. Then 16 different functions and their derivatives. Then composite function. Composite function derivative we obtain by rules, scalar multiple rule, sum rule, product rule and quotient rule. Okay, so then thereafter we have to do function of a function type derivative. Function of a function type derivative. And again we have two different function type we call exponential and parametric. Exponential functions derivative, parametric function derivative. Okay. Then we can do this differentiation repeatedly. This differentiation we can do repeatedly. Then we can get higher order derivatives. First derivative, second derivative, third derivative and so on. We can get higher order derivatives. Then all these cases I have given function like y equal fx. That means y have subjected. Y has subjected, no? Then there can be function that not subjected y. Okay? Like sin xy plus y square plus 2 likewise. In previous all cases I have subjected, but there can be those type of function we call implicit functions. Then we need to know how to differentiate those functions. Okay. What into lag gamma